In this video, we're going to talk about what are called Cauchy's inequalities. And these are inequalities that tell us about the boundedness of the kth derivative. So this is going to use the formula that we derived in the previous video, that if we have a function that's holomorphic on a region G, then the kth derivative has a nice formula. So it's going to be k factorial over 2 pi I times the integral over some nice positively oriented, piecewise smooth, closed, simple curve gamma. In particular, I'm going to use just the circle of radius r centered at w, where w is the value that we're plugging into the function here. So it's just some fixed complex constant. And then over here, we're going to have f of z over z minus w to the k plus 1 dz. Okay, so this is a special case of what we derived above. Okay, so these are the kth derivatives of f. And in particular, if I look at the modulus of the kth derivative, we can apply the modulus theorem that we have before. So, so this is going to be equal to k factorial over 2 pi, because the modulus of I is 1. So the modulus of 2 pi I is just 2 pi, times the modulus of the circle. So this is the integral over the circle, f of z over z minus w to the k plus 1 dz. Okay, and then we're going to apply the what I call the ML theorem, that this is less than or equal to the maximum times the length. So this is going to be less than or equal to k factorial times 2 pi I times the maximum value of z being in gamma here being the circle centered at w of radius r, of the modulus of f of z over z minus w to the k plus 1 times the length of this curve, the circle centered at w of radius r. Okay, of course, the length is 2 pi r. Also, one thing is that if z is in the circle centered at w of radius r, then z minus w has modulus r. So this is going to be, and there shouldn't be an I here because we took the modulus, so that I is gone. This is going to be the, let's see, the maximum value where z is in this circle of the modulus of f of z times 1 over r to the k plus 1, because we know each of these, so z minus w is going to have modulus r. So this will be r to the k plus 1 times the length of the circle, which of course we know is 2 pi r. And so this is going to be equal to, a lot of stuff cancels. The 2 pi's cancel, one of the r's cancels. This is going to be k factorial times k factorial over r to the k times the maximum that z is in this circle. So what we get is the following result. So here I've actually written a mathematical result the way that it might have been originally discovered, is instead of stating what the theorem is and then proving it, usually the proof actually comes first. And so here's what we'll call the theorem. Okay, so if f is holomorphic on a region G, then it turns out that the kth derivative of f at whatever point w is going to be less than or equal to k factorial over r to the k times m, where m is the maximum value that the function takes over this circle. Okay, and so that's what our result says. Okay, so let m be that maximum, and then the kth derivative has that bound. Okay, so these are called Cauchy's inequalities. These are going to be very useful for proving different results from here on out, at least for a little bit.